lesson in Math 8. Today we are going to be focusing on slope. Good old friend slope. Everything that you've done in math up to this point has directed you to this moment where we start talking about slope very specifically. Now I've mentioned it here and there in my previous videos and our previous lessons. We're going to talk very explicitly about slope today. As we get going into slope, the figure shows three right triangles, each with its longest side on the same line. So talking about this line right here. This says that I would give you two triangles, but we're actually going to go ahead and do all three just to make sure that we see a constant piece with this. Explain why the two triangles, in this case we're going to talk about the three triangles, are similar. The very first thing we're going to do is let's look at triangle ABC. When we look at triangle ABC, we talk about this table down here and complete this table. And we have to look at these pieces about the vertical side and the horizontal side. The vertical side of this triangle is 3 units tall. The horizontal side is 4 units tall. And then we create a ratio that bases this on the vertical side divided by the horizontal side. And the way that we'll write this is in the form of a fraction. And so we would see that the vertical side of 3 divided by 4 would be our fraction. Let's go ahead and look at triangle CDE, the next one right here. We see the vertical side is 6 units long. The horizontal side is 1, 2, 3, 4, 5, 6, 7, 8 units long for a ratio of 6/8. And then the final one is this little guy right here, triangle FGH. We see that the vertical side appears to be 1.5 or 1 5/10. Horizontal side is 2, and we have a fraction of 1 5/10 over 2, or divided by 2. What do you notice about these three fractions? Well, if we reduce these fractions, we see that 6/8 becomes 3/4. And we work off of the other fraction by a dilation of 2 so that we can double the numerator, double the denominator. We get 3/4. So as we can see that each of these three triangles, they all have the exact same slope. When we look at that slope, this ratio, we talk about that vertical side compared to the horizontal side. When we talk about the ratio that we work with slope, we are talking about the change in y divided by the change in x, which is also known as rise over run. So as we come to know slope, these are the pieces that we'll go ahead and get used to, is that we talk about the change in y compared to the change in x. We always have this as our slope. Let's go ahead and see how that works in the next problem. Next problem talks about multiple lines with the same slope. Now before we move on with slope, I want to give a quick definition of slope. When we talk about slope, we are talking about a ratio. Oops, tried to write ration. Ratio that measures the steepness of a line. That ratio is written generally as a fraction. You will occasionally see it as whole numbers or as decimals, but we typically write slope as a ratio that represents the steepness of the line. When we're talking about drawing lines that have a slope of 3, we need to consider that and say, well, how can I write a ratio if it's just a single number? When we write that ratio, we change 3 into a fraction and recognize that that fraction of 3 can also be written as 3 divided by 1. Or 3 over 1. So what we're going to do when we draw our line is we're just simply going to pick a point anywhere here on this plane, and we're going to go ahead and rise 3, or change vertically 3, 1, 2, 3, run 1. Notice that on these positive numbers, positive will be going up, negative will be going down for the top numbers, and then positive going left and right. Positive will be to the right, negative will be to the left. So from here, let's go ahead and do another one. 1, 2, 3, run 1. We see that constant pattern. 1, 2, 3, run 1. And we take our ruler and we draw a straight line. By the way, if you don't have a ruler, please grab one. Then let's go ahead and do it again. We'll draw another line. Let's just start right here this time. Rise 1, 2, 3, run 1. 1, 2, 3, run 1. Rise 1, 2, 3, run 1. Run out of space on here. The more points that you draw, the straighter the line you're going to get. And then what do you notice about the two lines? If you said that the two lines are parallel, you are right. Let's go ahead and do another couple of lines. Draw two lines with the slope of 1/2. And what do you notice about the two lines? Let's go ahead and start this line right here. 1/2, so we take a look at the top number. Ratio measures steepness of a line. Remember that is rise over run. So the change in y or the change in x. In this case, we're going to rise 1, run 2, plot a point, rise 1, run 2, plot a point, rise 1, run 2. We see that a pattern develops all the way across that page, so we can continue to follow it. And because of that pattern, that constant ratio, what we end up with is a nice straight line. These straight lines, what we call this is a linear pattern. Linear pattern, which means that linear gives us a straight line. That word right there, linear, understanding that linear means straight line is vital to everything that you're going to do with math from now on. When we speak of linear, we will assume that you understand that linear, that when we're talking about linear, we're talking about any kind of pattern that makes a straight line because it has a slope or a constant rate. Let's go ahead and do another slope of 1/2. Let's go ahead and put this one, let's start up here. And let's go ahead and rise 1, run 2. We're going to go ahead and intersect these two lines. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. We see that pattern continues. We can draw that pattern all the way across the page. And then when we look at these two lines after they're drawn, what can we say about the two lines? Well, we could actually say that those lines are also parallel. Whoops, parallel. When we look at lines that have the same slope, we will always have parallel lines. So we could say that piece parallel. This is our conclusion for this little section. Parallel lines have equal slopes. Very good. Now, real quick, I just want to give you a taste of this one. This says, as we learn more about lines, we occasionally have to consider perfectly vertical lines. And perfectly vertical lines, they have a very special case, and we have to treat them differently. It says, think about applying what you've learned in the last couple of activities to the case of vertical lines. What is the same? What is the difference? When we talk about vertical lines and we talk about rise and run, we need to understand that there's actually zero run. When we talk about rise over run, every single time we look at this, the run value on the bottom is 0. When we think about a vertical line, say if we come back up here to our graph or our table or our plane here, and we graph a line on that plane, what we recognize with a vertical line, as I try and measure that slope, as I rise 1, I don't actually run anywhere. And I rise, 7, and I don't run anywhere. My run, I can have an infinite amount of rise, which is my change in y, but then my run is always going to be 0. The same thing would be that the lines continue on, they're linear, but what's different is that my ratio here is always divided by 0. There's something very special about the fact that when I divide by 0, something happens, and it's not probably what you think. You might be thinking, oh yeah, well, anytime you divide by 0, the answer is 0. And that's not the case, because when we're talking about division, we're talking about dividing the numerator into parts that represent this value. And what that means, like if we had 4 divided by 0, that pattern would just continue to go on. We're trying to divide 4 by nothing. And when there's nothing there, we're actually not dividing into any other parts. So what we see with this on our calculators when we do this, sometimes we'll see something that says error, or we'll see something that says undef. And what this means right here is undefined, meaning that we actually can't find the slope because it can't be defined because it's a vertical line. So when we talk about vertical lines, we talk about vertical lines have a slope. I'll actually put this slope of vertical line is undefined, or we would say that it has no slope, not zero slope, no slope, meaning that slope does not exist for this line. Sometimes we'll also see the symbol that looks like this as an undefined symbol. So there's just a little introduction to no slope or undefined slope vertical lines. We'll see more of that as we get going. Let's talk about different slopes of different lines. Here's several lines that you see, 6 different planes. One is blank, is where our job is to match each of the lines shown with the slope from this list: 1/3, 2, 1, 25/100, 3 halves, and 1/2. One of the slopes, or given slopes, does not have a line to match, so we're going to draw that line when it comes time. So let's take a look at A. What we want to do with these is we want to essentially, if we see this triangle here on the bottom, we're looking at the same type of ratio with this, where we're looking for a rise and a run, and we're going to typically, we work from left to right, although slope will work from right to left, but typically I'm going to show everything from left to right. So from this point to this point, we're going to rise 1, 2, 3, run 1, 2. So we have a rise of 3, a run of 2, meaning that our slope equals 3 halves. So we can go ahead and cross that one off, or mark that one off as a done. Let's go ahead and look at our next one. I think I'm just going to go ahead and alternate colors each time. From here to here, we're going to rise 1, 2, and then run 1, 2, 3, 4, 5, 6 units for a slope of 2 divided by 6, which we know can simplify to 1/3. That one's done. This next one, we're going to rise 1, 2, 3, 4, 5 to that point, and then run 1, 2, 3, 4, 5 to that point, giving us a ratio of 5 divided by 5, which we know is equal to 1, telling us that our slope is 1. Now you might be thinking, well, Mr. Quilter, could I just go along this line and go rise 1, run 1, rise 1, run 1, rise, run 1? Absolutely, you sure can. And we see that that slope in its simplest form is just that: rise 1, run 1, rise 1, run 1. Likewise with the previous one right here of rise 1, run 3. And we run right back into the line using that slope. Let's talk about this next one here. We don't have any triangles drawn on it, so let's go ahead and pick a few points. If we look at these points, it appears that the line intersects commonly right here, and you might already see what that slope is, but we're going to go ahead and draw it on here. We'll start right here. We see a rise 1, 2, run 1. We see that pattern up here, rise 1, 2, run 1. We can see that pattern continues to repeat all the way through, so we see that our slope equals 2 divided by 1, or just simply 2. That slope is done. Let's go ahead and look at the next one. On B, let's go ahead and do the same thing here. Pick a point here, appears to intersect here and here. Let's go ahead and follow that ratio. Rise 1, run 1, 2, 3, 4, rise 1, 1, 2, 3, 4. We see that pattern continues, which is really good because then that means that we're going to get a straight line. So our slope here is equal to 1/4. I looked down my list, but the problem is I don't even see 1/4 there, but then you're saying, oh, silly guy, that's the same thing as 25/100. So like I said, sometimes the slope will be written as a decimal, not usually, but the slope can be written as a decimal in cases when we talk about a distance over a time, or when we talk about money or other things that are commonly written as a decimal. So that leaves us with the last one, a slope of 1/2. So go ahead and come on over here, just like what we did at the very beginning. Pick any point wherever you want. Go ahead and start there. And from that point, just follow our ratio, our constant rate. Rise 1, run 2. Pick up, draw a point. Rise 1, run 2. Draw a point. Rise 1, draw 2, or run 2. And what you'll see is you're going to get so good at this that you're just going to be able to start seeing that pattern on these smaller slopes. You're going to be able to draw them, but here's the test. We have to make sure that when we're talking about linear patterns such as this, we can lay a ruler down on there and we can get a straight line. If the line is not straight, then we messed up somewhere. There we go. In summary, we've introduced slope. So as we summarize through this, here is a line that's drawn on grid. There's also 4 right triangles that are drawn. Do you notice anything the triangles have in common? Well, as we look at this, what we're looking at is trying to relate slope and dilation together. We recognize that as these lines are drawn, or as these triangles, we notice something in common is that they all have the exact same line that's running through on their longest side. That helps us because then we can determine that they should, in theory, all of them have the exact same slope. I don't know what I did with my highlighter, so I'm going to go ahead and draw this one in orange. But we should understand that anything along this line, any point that's along this line, or distance between any 2 points along this line, is going to give us the exact same slope. So when we look at these triangles here, like let's say that we look at this first one that's up here across the top, we see that this triangle has a rise of 4 and a run of 6. And when we look into our drawing, or we look down here at the bottom, we have all these slopes that are drawn here. We see that 4 divided by 6 is going to be the same thing as 2/3. We see the same thing on this triangle down here at the bottom. From B, our triangle, I guess there's no point right here, so maybe we could call that one point F. We have this triangle here that runs along segment BD at its longest side. And we have a ratio again of 4 divided by 6. We see in its simple form right here, we see a rise of 2 and a run of 3. And then we see this little tiny guy right here. Oh, baby. Let's fix that. Sorry about that. We see this little tiny guy that gives us a ratio of 2/3 over 1. Well, we know that anything divided by 1 is simply itself. We see this ratio here of 4/6. We see that one twice. It's 2/3. And then we see just the one that's already simplified of 2/3. We recognize that these 4 triangles are all examples of what we call slope triangles. One side of this triangle is the slope, or the one side of a slope triangle is on the line. One side is vertical and the other side is horizontal. The slope, as we talk about this, is the quotient of the length of the vertical side and the length of the horizontal side. And what we commonly call the change in y over change in x, or rise over run, or rise divided by run. This number is the same for all slope triangles for the same line, because all the slopes in this triangle have the same line that creates similarity between them. What I could really do with this is I could actually take this triangle right here and I could translate this triangle from A, excuse me, I'm sorry about that, from A to B, and I would see that that little triangle right there would actually line up right here in the spot, and I see the exact same triangle translated down. I could also say that this larger triangle right here, I could dilate this triangle by a scale factor. In this case, I see the distance from D to C is half that of D to B. I could dilate this triangle right here by a scale factor of 1/2 from center B, and I would get the exact same triangles we see right up here that goes off of AB, or the one that I've already drawn. As you can see, that dilation plays directly into this. We see that the ratio that we've used from D to C and D to B can be a piece that's dilated by a scale factor of 2 to go from 2/3 to 4/6, or by a scale factor of 1/2 to go from 4/6 to 2/3. This is slope. Welcome to it. We're going to be seeing a lot of slope throughout the rest of the year. We are also going to be seeing a lot of slope here in the short term, but slope will be a very, very big part of your mathematical experience from now on through Algebra 2 and beyond. So make sure you get to be real good friends with slope. And if you have any questions, let me know. Don't you dare give up.